Ladies and gentlemen, welcome to the fourth lecture on module 1 of offshore structures and materials. Let us quickly look at the outline of this lecture. We will discuss about complaint type of offshore structures as continuation of the previous lecture. In the present lecture, we will focus on studies related to semi-submersibles and FPSOs. What are semi-submersibles? Semi-submersibles are also complaint type drilling structures which are one amongst the oldest offshore exploratory rigs used for oil exploration in deep sea. They typically operate in wetlands and swamps standing in the water depths up to 30 meters. Submersibles include posted barges, bottle types, arctic types and inland barges. A semi-submersible rig floats on the water surface when moved from one drilling site to another. It is similar to what we have seen in the last lecture about jack-up rigs. When it reaches the destination, certain compartments are flooded, which are what we call as ballasted, to submerge the lower part of the rig to the sea floor. The lower part of the rig rests on the sea floor and therefore the drilling operation can continue. With the base of the rig in contact with the ocean bottom, it has got a very good resistance for the encountered lateral forces like wind forces, wave forces and currents. They have a very little effect on the structural motion of semi-submersibles. They typically have 2 or more air-filled steel floats. We call them as pontoons. They are similar to what we have as pontoon member in tension leg platforms. There can be either 1 or 2 large size air filled floats on which the rig rests and held in position by massive anchors to which these semi-submersibles will be anchored to the sea floor. Because the pontoons are usually submerged a few feet below the water surface, they have a very high stability of operation during drilling, and it is because of this reason they are called as semi-submersibles. They have a very good stability compared to that of a drilling ship, because drilling ship actually floats in water while drilling is carried over, whereas semi-submersibles rests on the sea floor when the drilling is carried over. A semi-submersible can be easily towed or moved from one site to another new one by towboats. Some semi-submersibles are also equipped with what we call self-propelled housing inbuilt power units, which can be used to propel them from one site to another site. If you look at the table where we are talking about the number of semi-submersible platforms installed worldwide, and the category is related to the water depth at which they are installed. Less than about 200 meter water depth, you have got 11 platforms installed, whereas from 200 to 500 you have got about 16, from 500 to 1000 you have got about 9, and more than about 2000 you have only one semi-submersible so far being working. Semi-submersibles are actually used for various water depths varying in the range from 100 meters up to 2000 meters. There can be only one exception, which is Genesee A, whereas this platform was used less than about 100 meter depth. If you look at the deepest and shallowest platforms of semi-submersibles as on now, Atlantis, Blind Faith and Thunder Horse are different kinds of deepest platforms which are all located in the United States, whereas the shallowest platforms mainly are located in Brazil. If you look at the photograph of Blind Faith, which is one of the deepest semi-submersible installed in the waters of United States, installed in the year 2001 at a water depth of about 1981 meters, 65,000 barrels of crude oil per day is the capacity of production of this platform. 55 million cubic feet of natural gas per day is what is producing. The other type of offshore compliant platform is what we call as FPSO. FPSO abbreviates for floating production, storage and offloading systems. Essentially the offloading is done onto a shuttle tanker, which is actually the crude oil extruded from the seafloor. FPSOs are actually typically converted or newly built tankers actually. They produce and store hydrocarbon which are subsequently transported by other vessels to the terminals or deep water ports. You also have something called FPS, where there is no offloading system available. In this, they are what we call floating production systems. The universal term FPS refers to all production facilities that float rather than are structurally supported by seafloor. Ladies and gentlemen, in the previous lectures you have seen there are offshore structures which are bottom supported, for example steel jacket platforms which are anchored to the seafloor through piles. You have also seen bottom supported structures which are resting on its self weight, for example gravity based structures or GBS. We have also seen compliant structures like tensional platforms which are anchored down to the seabed using tethers or cables. So, in general floating production system refers to all those production facilities which actually float rather than they are supported by the seafloor. This of course includes TLP, spar, semi-submersibles, ship shape vessels, etc. All of them come under the common bracket what we call as floating production systems. The term is also frequently used to describe the general category of floating production facilities that do not have on-site storage. The term is also used by American Bureau of Shipping to describe a classification of floating production facility that do not have a storage capability in general. When we talk about FSO in the literature, they are otherwise called floating storage and offloading system. Ladies and gentlemen, understand here that there is no production unit attached to this kind of floating systems. Like the FPSOs, they are actually typically converted or newly built tankers which are essentially used as storage or offloading systems. They differ from FPSO because they do not have any processing equipment which are essentially required for production. The liquid are stored for shipment to another location for processing. Essentially they are floating storage units. They can be also used as offloading systems. Now the question comes, what do we understand by offloading? Offloading is a term related to transfer of produced hydrocarbon from an offshore facility into a shuttle tanker or a barge for transporting it to further deep water ports. An FPSO actually relies on a subsea technology for production of hydrocarbon, and this would involve typically pipeline export of produced gas with shuttle tanker that transports the explored hydrocarbon from offshore side to onshore, what we call as offloading systems. FPSOs essentially are relatively insensitive to water depth because essentially they are floating systems. As we understand, for example like TLP, any floating system which is not resting on the sea floor do attract less forces when they are installed in deep waters. To date, nearly all FPSOs have been installed at a depth which is greater than about 1000 meters. That is a great advantage. Therefore, FPSOs are generally used for deep water oil exploration. Some units are meant for production, some of them are meant for only storage and offloading. So, it can be either FPSO or FSO. Ladies and gentlemen, here is the photograph of an FPSO which is Greater Plutonio. You can look at the complicated topside facility which has been seen in the figure here. It houses all kinds of equipments that are required for production unit like a drilling derrick like living quarters, helipad, flash stack, complicated machineries used for power generation, used for processing, etc. We can easily recognize from this picture that FPSO is nothing but a conventional barge or a tanker converted for floating production design. This picture shows the different layout of subsea trees and flow lines which are attached to FPSO. These are two FPSOs, one can be an offloading tanker, one can be again a storage vessel, can be an FSO or a production facility which is having FPSO, can have different drilling units, different drilling location sites which are all connected to an FPSO as seen here. This is what we call as subsea layout of subsea trees. It is a typical figure which shows different components of an FPSO. For example, if you look at the flash stack here, it is having gas turbine, there is an off-take system which is having an offloading facility, there is a central moon pool which is having specifications and standards that can house actually the risers through which the flexible risers can enter for production systems. It contains bridge, main control room and heli deck and living quarters on the top deck. In the middle deck it contains lot of machinery rooms which we call them as high and low voltage rooms, engine and boiler rooms on the upper hull and engine and boiler rooms on the lower hull. Of course, transformers and switch rooms are located at the lower as well as upper hull. The bottommost hull will have thruster rooms, azimuth thrusters and thruster rooms on either side of the FPSO, whereas the chain mooring system will be attached to the lowest hull of this. If you look at the hull configuration of an FPSO, the hull of an FPSO is typically ship shaped. Of course, recent research has been done in IIT Madras to study semi-submerged and FPSOs which are non-ship shaped. I will discuss these very briefly at the end of my presentation later. So, a hull of an FPSO can be a mono hull structure, that is having a single hull, such as spar or purposefully built barge shaped vessels. The typical FPSO can be characterized simply as a tanker with dimensions as follows. The length can vary anywhere from 200 meters to 400 meters, whereas the breadth can vary from 30 to 60 meters and the depth or the height can vary from 20 to 30 meters. Of those systems deployed to date, most of them have conversions of smaller and older tankers. Ladies and gentlemen, generally FPSOs are very rarely newly built, they are actually converted modules of old tankers which has been used for production, storage and offloading facilities in the sea. One of the major advantage of converting the existing vessel to an FPSO is saving of time. You can use that for rapidly for the first production. For example, if you have a newly purpose built FPSO, it will take few years to commission it. Instead of that, people generally go for conversion of existing floating barges to FPSOs. If you look at the processing system which is deployed on an FPSO, the main topside processing system consists of various components which can be used for processing and production of crude oil, gas and water separation units. There can be requirements of water injection equipments, there can be gas compression units, there can be chemical injection units and equipments. It will also house control systems for subsea production equipment. Associated piping will also form a part of the processing system of an FPSO. Let us quickly look at the mooring and station keeping of an FPSO. There are two options for station keeping of an FPSO. Majority of existing FPSO employ a fixed mooring system which uses anchors and anchor lines hold it in position. FPSOs can also use dynamically position systems, what we call as DPS, that employs a series of thrusters and positioning technology which depends on the satellite and GPS receivers, etc. The fixed mooring system can either be permanent or temporary. Most FPSOs deploy permanently moored system. Actually, they are designed to remain at the location throughout all the anticipated environmental situations. They are not decommissioned even though the weather can become rough. There are very few cases where they have been designed to be disconnected under severe weather conditions such as typhoons and hurricanes or iceberg thrusts. If you look at the mooring systems which are generally equipped for an FPSO, we got two classified mooring systems which are turret mooring system. One is an internal, other is external. In internal mooring systems, we got large internal turret mooring system, small internal turret mooring system, buoyant turret mooring system, and submerged turret protection system. As you can see very clearly here, the diameter of the internal mooring system for a large compared to that of small is very different, whereas for a submerged turret protection system, the turret mooring system is submerged in the FPSO vessel itself, whereas in all other three cases they are housed on the top hull. If you look at the external mooring system, you can see that the protection risers are cantilevered away from the FPSOs, whereas in internal mooring systems there is a moon pool which passes through the semi-submerged or the FPSO through which drilling takes place. So that is why these kinds of mooring are called internal, whereas these kinds of mooring are called external because they cantilever out from the FPSO hulls. If you look at the detailed anatomy of the turret mooring system, you see you have got actually a swivel stack at the top. The swivel acts as a maintenance gantry is housed on the top hull, whereas it is attached to a rotating crane which is used to lay the risers or the mooring lines which comes in rolls. There is a pipe manifold through which the risers are passed through. The turret cylinder is equipped in the moon pool, and the turret aluminous is a component with an annular covering of the turret mooring which is housed and resting on the main bearing, whereas the external moon pool is what you see here, which is cut in an FPSO, and there is a chain stopper which prevents the backflow of chains or the mooring lines into the turret system. This is what you see is a riser which passes through the moon pool, which is essentially used for production drilling. It is a very typical photograph of an FPSO which is being used for catering to different lines on subsea trees. You can see here these are all the mooring lines, these are all the production risers, these are the mooring lines and production risers being spread in different segments. All of them are connected to the mooring system here, which is being used for production, storage as well as offloading in this case. The advantage of a disconnectable mooring system, as you see here, is you can demobilize the personnel and assets during emergency. As we understand, very interestingly, when you connect a mooring system or a riser to an FPSO or any floating system, there will be always a coupled action imposed on the floating system by the dynamic sway action of the riser or the mooring cables. In such situation, in case of any emergency, you want to really safeguard the personnel or assets, you can disconnect the mooring system from the FPSO so that the FPSO or the floating system can be saved because of the coupling action imposed on by the risers onto the floating systems. Let us quickly talk about the risers which are deployed in FPSOs for oil production. Risers actually provide path for transporting the produced fluid to the processing equipment which are housed on the top hull of an FPSO. Gas export lines which are used in addition to the shuttle tanker operation will also exit from the FPSO in the similar manner as that of the riser. Riser system associated with an FPSO can be integrated to the mooring system for a turret moored system, as we just now saw in the previous slide. However, when you connect integrally the riser system with the turret mooring system, you must design it for the coupled analysis as I mentioned in the previous slide. In an FPSO mooring system can always have a fixed point system, which is generally used in the case of semi submersibles. In that case, risers can be hung off the side of the facility, as we see in the case of external turret mooring system. If you look at the power generation units which are generally put on semi submersed and FPSOs, the design basis for power supply focus on three categories. One is the mains power supply, which is required for all electrical functions during normal operation. Other is an essential power supply, which requires for startup operations or shutdown of facilities as required. The third one is a vital, which is an emergency power supply, which is required when you want to have a survival at sea situation arises. In addition to the conventional power generation needed, FPSO also require power for thrusters used in support for the mooring system. If you look at the storage of an FPSO, the FPSO installed to date have storage capacity ranging up to 2.3 million barrels. The storage capacity of any FPSO actually depends on many parameters. For example, depends on the ship size, the availability and size of the offtake vessel through which the stored oil can be transported to other production or processing facility from the FPSO, the projected downtime, basically it is the time of operation at which the FPSO will remain in sea for production, and of course the cargo destination, how far is the site of operation from the shore. Now let us look very briefly about the offtake systems which are used in FPSOs. Offtake essentially means offloading. Offloading is a term related to transferring the produced oil or hydrocarbon from the barge or the floating system to another location. If you look at the figure here, this is an FPSO which is connecting different wells from which drilling is taking place. You also have drilling platforms from which the hydrocarbon is transported to an FPSO. You may wonder why the explode hydrocarbon from a drilling platform should be transported to an FPSO. As you recollect, these floating production systems may not have larger capacity to store the explode hydrocarbon. FPSO has S standing for storage, so there can be large volume of hydrocarbon can be stored. Therefore, the produced hydrocarbon is actually transported to FPSO, as you see here. Further from the FPSO, they have been transferred to offloading system from a buoy. So the liquid hydrocarbons from an FPSO are offloaded to a shuttle tanker, which further transports it to onshore. Offtake systems actually include equipments associated with storage tanks of shuttle tanker, the mooring lines, the buoys and transfer hoses. So as a total, for example, the equipment associated with storage tanks, the mooring lines which are used for holding down the offloading system, the buoys which are used for transferring the crude oil from FPSO to offloading system, and of course the transfer hoses put together is what we call as an offtake system or offloading system. Common offtake systems can be tandem, side by side offtake system, single point offtake system or remote systems. I will show you some pictures of side by side and tandem. This is an FPSO equipped with tandem offloading system. You can see this is my FPSO, whereas along with this at tandem I have an offloading system which is towed along with this together. This is what they call tandem offloading system associated with FPSO, whereas in this case an FPSO which is used for production is also equipped with a side by side offloading system. So, this is actually a barge or a tanker which has large capacity to store the produced hydrocarbon. So, it is actually a twin ship which sails together, whereas this is anchored and the production takes place from here. This is anchored to the FPSO here, and the produced hydrocarbon from this location is offloaded to this barge. So, this is what we call side by side offloading system, whereas in this case I call them as a tandem offloading system. If you look at the FPSOs and offloading system which are constructed as on today, we have got 3 numbers constructed in North America and 14 in South America. Large of them are in Africa and Europe, and of course few of them in Australia and Asia. Totally there are around 86 FPSOs constructed so far. Look at the water depth where they have been deployed. Less than 100 meters you got 17 numbers, whereas from 1000 to 2000 meters you got majority of 22 numbers. 33 platforms, out of which 86 are on an average operating at a depth of more than 500 meters. So, FPSOs are offshore production systems which are used for oil production exploration in deep waters. If you look at the location of FPSOs, the deepest and the shallowest, you will see the deepest operation is about 2.15 kilometer deep, located in Brazil, whereas the shallowest can be as close as 13 meter in Nigerian waters. If you look at a brief overview of different bottom supported vertically moved structures, we have seen very detailed discussion on fixed platforms. We have also discussed, as we go for deeper waters, compliant towers where we call articulated towers. Further, if you want to go for deeper exploration, we have discussed about floating structures which is compliant in nature, where we call TLP is an unique hybrid platform which has got combination of 2 set of different natural periods of the structural system. You can also have a mini TLP where you got a separate anchoring system. Here the tendons or the teethers are through in this case, whereas you have got the projection systems from which the tendons or teethers are anchored to the seabed. If you look at a comprehensive view of different kinds of platforms for different water depths, up to 1500 feet you can use fixed platforms, from 1500 to 3000 you can use compliant towers, you can use C star from 500 to 3500 feet, you can use floating production systems FPS up to 6000 feet, can use TLPs up to 7000 feet, can use subsea systems up to 7000 feet, can use spars from 2000 to 10,000 feet. This gives a very comprehensive overview of different kinds of offshore structural systems which can be deployed from shallow water, medium water to deep water to ultra deep waters. If you look at the floating production and subsea systems, you have combination of spar platforms, floating production systems and floating production storage and offloading facility where you got a shuttle tanker in tandem attached with the FPSO. Here is a comprehensive view of different kinds of platforms which has been shown in this picture. Ladies and gentlemen, I want you to name few of them. Let us try to name few of them here. Do you think this is an offshore platform? This is actually a platform housed to locate the windmill on the top. This is a truss type platform which can be used. Can you name what is this kind of platform? This is a floating production system which is having the pontoon and the column members. So, this is a typical tension angular platform because you can see series of teethers anchored to the sea floor. This is maybe a drill ship or a semi submersible which is moored to the sea floor. This can be again a tensioner platform and a semi submersible which can be used for exploration and production in deep waters. Let us quickly look at the drilling platforms in general which are used for offshore drilling. There are basically two types of drilling platforms. One is what we call as a movable drilling rig, other is a permanent drilling rig. The former is actually used for exploration purposes, while the latter is actually used for production purposes. I can give you some examples in this photograph. You can see a floating production platform. It is a typical example of a semi submersible and a drill ship. I want you to name this particular type of structure. We have seen this in the previous lecture. Yes, you are able to recollect correctly, this is a jack-up rig. Now when the rig is actually floating, the legs are all raised up, that is why it is called jack-up rig. I hope you have understood some basics of drilling from this lecture. Thank you.